The fuel flows out of the fuel tank and through a pre-filter. Two versions are available. The first unit is a replaceable spin-on element with a 140 micron rating. The second unit is rated at 25 micron and it contains a water and fuel sensor, water drain, and coolant passages that can be plumbed into the heater hoses to prevent fuel gelling in cold weather. Fuel flows from the pre-filter to the lift pump. This pump runs for the first 2 minutes after the key is turned on to ensure that fuel gets up to the gear pump quickly for easier starting. At 1 psi of pressure, a valve in the IFSM housing opens to allow some lift pump output to flow to the drain line. This bypassing of fuel helps to bleed any air from the supply passages. When the engine starts, the gear pump can draw fuel directly from the inlet fitting through the anti-drainback valve. After 2 minutes of operation, the lift pump shuts down. The gear pump then draws all of the fuel directly from the inlet fitting past the anti-drainback valve. The gear pump provides the high volume and constant pressure needed for the system to meter properly. The 380 psi high-pressure regulator installed in the IFSM between the gear pump and the filter is a safety valve to prevent damage in case of a stuck fuel shutoff valve or other blockage in the fuel lines after the gear pump. Any fuel flowing through the high-pressure regulator is dumped back to the drain line in the IFSM and then returned to the fuel tank. Fuel under pressure flows to the fuel filter. This filter is a 98% efficient 15-micron filter. After contaminants are removed, the filtered fuel flows to the shutoff valve. When the key switch is in the crank or run position, the ECM sends a signal to open the fuel shutoff valve. Fuel flows past the open shutoff valve into the rail that supplies the actuators. The 250 psi fuel system regulator allows excess fuel to flow out of the rail to limit and maintain the pressure. This excess fuel flows through external tubing to a passage in the ECM cooling plate before going through return tubing to the inlet side of the fuel pump. With a constant pressure at the actuators, the ECM sends signals to the actuators to control the fuel flow to the injectors. Each of the actuators is a normally closed on-off device. The actuators open when they receive a signal from the ECM. Opening the actuator allows fuel to flow to its connected timing or metering rail. In this way, the ECM controls the volume of fuel flowing to the injectors. With the two-bank design and the firing order, the ECM functions fast enough to have individual control of the injectors. When the engine is shut down, the fuel trapped between the actuators and the injectors absorbs heat from surrounding engine components. As the temperature of the fuel increases, the fuel expands and increases pressure in the metering supply rails. If allowed to build, this pressure would push fuel through the open injector into the cylinder. This would result in increased cranking resistance and hard starting while the engine is still warm. A passage drilled between the metering supply rail and the drain passage in the IFSM, along with a check valve mounted in each metering actuator, provides fuel venting to reduce this pressure. An 8/1000 orifice is installed into the drilling to limit fuel flow to the drain passage during normal engine operation. The passages from the timing and metering actuators connect to internal passages in the cylinder head. These passages supply fuel to the front and rear bank of injectors. The ISX CM870 injector assembly consists of the upper plunger, timing check valve, inlet screen, rail metering check valve, lower plunger with trapped volume spill or TVS port, lower plunger spring, timing plunger spring, spill regulator, and leakage vent. The injection cycle begins with the injector plunger mechanically held against the nozzle seat until the end of the exhaust stroke. The injector rocker lever is on the outer base circle of the camshaft. At this point, all three of the plungers are at the bottom of their travel. After the exhaust valve closes, the injector rocker lever begins to move off of the outer base circle. The upper plunger begins to move upward under spring force. The timing plunger remains in contact with the upper plunger, and the lower plunger remains in contact with the timing plunger due to their respective springs. As the lower plunger continues to move upward, the metering port is opened. Shortly after opening the metering port, the metering plunger contacts the stop in the injector. The upper and timing plungers continue to move upward. Just before the spring guide contacts the top stop, the timing feed port is opened. With the plungers in this position, both the timing and metering ports are open. However, no fuel flows into the injector until the ECM sends a signal for the timing and metering actuators to open. The timing and metering actuators are then opened at the appropriate time and duration to supply the desired amount of fuel through the metering and timing check valves into each chamber. By varying the amount of time that the timing and metering actuators are open, the ECM controls the amount of fuel metered into the timing and metering chambers. Increasing the amount of time the metering actuator is open increases the amount of fuel metered into the injector and injected into the cylinder. Allowing the metering actuator to be open for a shorter period of time allows less fuel to be metered into the injector. As the fuel enters the timing chamber, the fuel pressure travels between the timing plunger and the upper plunger through a groove in the top of the timing plunger. The fuel pressure then forces the timing plunger down against spring pressure. As the upper plunger begins its downward travel and closes the timing feed port, it contacts the column of fuel in the timing chamber. This trapped fuel acts as a hydraulic link between the upper and timing plungers. The upper and timing plungers move down together. The timing check valve prevents fuel from flowing back out of the timing chamber. The amount of fuel in the timing chamber determines the starting position for the timing plunger. With more fuel in the timing chamber, as the upper plunger begins its downward travel, the timing plunger begins its downward travel from a lower position. This advances the timing. A shorter period of time that the timing actuator is open allows less fuel into the timing chamber. This causes the timing plunger to begin its travel from a higher position, which causes the timing to retard. When the timing plunger contacts the lower plunger, all three plungers travel downward together. The metering check valve prevents fuel from flowing back out of the metering chamber. The check valves stop the initial flow of fuel back out of the injector. However, the plungers move past the inlet ports prior to injection to cut off the flow path back to the check valves. When the lower plunger reaches the solid fuel in the metering chamber, pressure in the chamber rises, resulting in the fuel injecting into the cylinder. Injection continues until the annular groove in the lower plunger bore aligns with the trapped volume spill or TVS port. This allows the small amount of fuel remaining trapped in the metering chamber to flow out of the injector to the drain line, providing a sharp end to injection and relieving fuel pressure in the metering chamber. At the same time, the timing spill port is open to drain. As the upper plunger continues to move downward, the timing fuel spills into the injector drain line. The ring valve on the injector flexes to regulate the timing spill flow. This elliptical flexing of the ring valve prevents the pressure from dropping too rapidly to keep the lower plunger forced onto its seat. As the injector rocker lever again reaches the outer base circle of the camshaft, the timing plunger is again in contact with both the upper and lower plungers. The downward force of the rocker lever causes a mechanical crush to push fuel out of the metering and timing chambers. Fuel from the injector drain flows through internal drillings in the cylinder head to the IFSM. A fitting near the rear of the IFSM allows fuel to return to the fuel tank through the fuel return line. The injector sleeve relies on pressure from the injector to help it seal against the cylinder head. Without the injector installed, coolant is likely to leak past the sleeve and into the cylinder. Therefore, before removing injectors, the coolant must be drained at least below the injector level. As an alternative to draining the coolant, you can use the coolant dam tool, number 3824319, to hold the coolant in the engine while the injectors are out. With the valve cover removed, disconnect the engine brake wiring harness connectors from the brake solenoids. When loosening the rocker lever adjusting screws, do not use an air gun or other power driver. The nose pads are swaged into the adjusting screw, and excessive force can pull the pad from the adjusting screw. If you are replacing one injector, you can remove the injector without having to completely remove the valve rocker lever shaft assemblies. However, the associated injector rocker lever assembly must be removed. If the valve rocker lever assembly is not removed, the rocker lever adjusting screws must be loosened enough to allow the removal of the intake crosshead and pivoting the exhaust crosshead toward the exhaust side of the engine. This will require the valves to be adjusted after the injector is installed. To remove all of the injectors, remove all of the valve and injector rocker lever shaft assemblies. Do not let the rockers come off of the shafts during removal. Remove the crossheads. Mark the crossheads so they can be installed in the same position from which they were removed. On engines equipped with an interbrake, one of the exhaust valves has a pin that extends through the crosshead so that the interbrake rocker can open that exhaust valve. These pins are not retained in the crosshead and may fall out during crosshead removal. Loosen the injector hold-down clamp cap screw. Remove the clamp. A special puller is needed for injector removal. Insert the puller into the hole in the injector. Lift the injector out of the bore and remove the injector. Clean any debris from the injector bore. Install 4 new O-rings on the injector body. The O-rings are different sizes and must be installed in the correct location. Lubricate the O-rings with clean engine oil. Place the injectors in the injector bore. Do not attempt to seat the injector in the bore. Install the injector hold-down clamp and cap screw. Torque the cap screw to specification. The hold-down clamp will seat the injector in its bore as it is tightened. Install the crossheads, rocker shaft assemblies, brake solenoids, and brake harness. Additional information on the overhead set procedures are found in the overhead section of this program. Before beginning any service procedure, especially when working on the fuel system, you should disconnect the battery for safety. To remove the IFSM, begin by disconnecting the wiring from the air pressure and temperature sensors and removing the sensors. Disconnect the fueling and timing actuators, fuel shutoff valve, fuel lift pump, fuel pressure sensor, and the fuel temperature sensor mounted on the IFSM. To provide extra clearance and allow the wiring harness to move out of the way, disconnect the wiring to the oil pressure and temperature sensors. Disconnect the EGR differential pressure sensor tubes at the Venturi-style orifice. When disconnecting the wiring for the sensor, do not try to remove the connector at the sensor. It is fixed to the sensor with epoxy. Use the connector further up the wiring harness to disconnect the sensor. Then remove the differential pressure sensor and adapter. Remove the oil dipstick tube support and bracket. Disconnect the fuel lines that carry fuel to and from the ECM cooling plate and the fuel supply and fuel drain lines. Remove the cap screw that retains the cam position sensor in the head, and then remove the accessory mounting bracket located above the IFSM. Remove the 4 remaining cap screws that mount the IFSM to the head. Remove the IFSM and the gasket. The gasket may be reused if it passes a visual inspection. To install the IFSM, hang the gasket and the IFSM on the 2 dowel rings. Install the IFSM cap screws. Install the accessory bracket and cam position sensor retainer bolt. Torque the accessory bracket cap screws and then torque the IFSM mounting cap screws. Install the fuel lines, the dipstick support and bracket. Install the EGR differential pressure sensor, adapter, and tubing. Connect the wiring harness connections to the oil sensors, lift pump, fuel shutoff valve, and fuel actuators. Install the air pressure and temperature sensors in the air intake and reconnect the battery. To remove any of the 4 actuators, disconnect the wiring harness as needed. Remove the 3 torque screws holding the actuator to the IFSM. Remove the actuator and 4 O-rings. When replacing the actuators, install new O-rings on the actuator. Place the actuator on the IFSM and install and torque the 3 torque screws. To remove the fuel dampers, the IFSM must first be removed. See the IFSM removal and installation section of this program for the IFSM removal procedure. Begin by loosening all 3 cap screws in the damper housing. Then remove the 2 cap screws that attach the damper assembly to the IFSM housing. Remove the 3rd cap screw and then remove the housing from the cover. Take out the spring steel diaphragm. Check for corrosion wear or damage and replace any parts that are unacceptable for reuse. The diaphragm is checked for hidden cracks by dropping it on a flat, hard surface. The diaphragm should have a clear ring. If the diaphragm produces a dull, flat sound when dropped, the diaphragm is cracked and must be replaced. Assemble the damper with new O-rings. Replace the steel diaphragm and nylon washer if needed. Install the sealing washer, damper assembly, and 3 cap screws. Torque the cap screws to the specified value and reinstall the IFSM. To remove the fuel lift pump, you must first remove the EGR differential pressure sensor and EGR differential pressure sensor tubes. Disconnect the wiring to the lift pump. The lift pump is bolted to a mounting plate and must not be removed from the plate. To remove the lift pump from the IFSM, remove the 4 Allen head cap screws that attach the mounting plate to the IFSM. Before installing the lift pump, make sure the mounting surfaces on the lift pump mounting plate and the IFSM are clean and free of cracks or other damage. Install a new gasket between the lift pump mounting plate and the IFSM. Install the 4 cap screws and torque them to specification. Finish the procedure by connecting the wiring and reinstalling the EGR differential pressure sensor and tubing. To remove the fuel pump, first disconnect the cooling plate return line from the back of the fuel pump. Remove the 4 Torx cap screws and remove the fuel pump. Before installing a fuel pump, make sure that the gasket surface on the pump and the IFSM are clean. Install a new gasket on the gear pump and using the 4 Torx cap screws, install the pump. Torque the cap screws to the specified torque. Complete the procedure by reinstalling the fuel line from the cooling plate to the back of the pump. To remove the anti-drainback valve, you must first remove the lift pump. The lift pump removal procedure is given elsewhere in this program. The anti-drainback valve is threaded into the IFSM in the passage that connects the lift pump, inlet fitting, and gear pump inlets. Remove the valve using an Allen wrench. To install the anti-drainback valve, check the O-ring and replace if necessary. Then place the valve on the Allen wrench and install it in the IFSM housing. Torque the valve to the value stated in the service literature. The lift pump bypass valve can only be reached by first removing the IFSM. See the IFSM removal procedure elsewhere in this program. The lift pump bypass valve is screwed into the IFSM from the back. To remove the valve, unscrew it using an Allen wrench. Inspect the valve for thread and sealing surface damage. The valve should flow in one direction and seal in the other. Flow is from the center hole of the hex through the valve. To install the lift pump bypass valve, thread it into the IFSM housing and torque it to the specified value. To remove the fuel pressure regulators, unscrew them from the IFSM housing. To install the regulator, inspect the O-rings and replace if necessary. Screw the regulator into the IFSM housing and tighten to the specified torque. For most installations, it will be necessary to remove the ECM before removing the cooling plate. Begin by disconnecting the wiring to the ECM. Remove the ECM mounting cap screws and ECM. Disconnect the 2 fuel lines on the cooling plate. Remove the 6 cooling plate mounting cap screws. Remove the cooling plate and insulating shield. Remove the 5 insulating washers and the 1 ground washer from the cooling plate mounting holes. Clean the cooling plate with an appropriate solvent and dry completely with compressed air. Install the ground washer in the upper left cap screw hole nearest the wiring harness. Install insulating washers in the other 5 mounting holes. Check the O-rings in the fuel fittings and replace them if they show any signs of damage. Using guide studs, install the cooling plate using a new insulator. Install the 6 mounting cap screws and torque to specification. Install the fuel lines, ECM, and wiring to complete the installation. The fuel system is self-bleeding. To prime the system, fill the fuel filter with clean fuel and install the filter on the filter head of the IFSM. Turn the key to the on position and let the lift pump run for 1 2-minute cycle. Start the engine. The engine may run rough for a few minutes while air is purged from the system. Before making any checks with the digital multimeter and pressure transducer adapter, you must first zero the adapter. Begin by setting the dial on the digital multimeter to the millivolt scale. Plug the meter into the adapter, aligning the red lead with the appropriate port on the multimeter. Turn the pressure transducer adapter on and check to make sure the red light is lit. This is your indication that the battery in the transducer is good. Install a quick connect fitting to the end of the hose on the adapter to vent the hose. Set the adapter to the desired scale. Zero the meter by turning the knob on the adapter until the meter displays 0. Remove the Quick Connect fitting. The meter is now ready for use. Connect the pressure transducer to the Quick Connect fitting at the suction side Quick Connect fitting at the top of the IFSM. Start the engine and operate it at rated speed and no load. Check the fuel inlet restriction. It should be no more than 8 inches of mercury for a clean pre-filter and no more than 12 inches of mercury for a used pre-filter. If the restriction exceeds specification, check the restriction at the IFSM fuel inlet fitting using adapter number ST434-2 to determine the location of the restriction. The maximum restriction at the inlet fitting is 5 inches of mercury. If the reading at the inlet fitting is within specification, the restriction is between the inlet and the gear pump. If the reading at the inlet exceeds specification, the restriction is between the tank and the IFSM. If the inlet restriction exceeds the specification, locate the restriction in the fuel supply by moving the gauge from one fitting to the next toward the fuel tank and taking readings. Locate the component or components causing the restriction and repair or replace them as necessary. If the pre-filter is the source of the restriction and a replacement filter element is not available, the pre-filter housing has been designed so a spin-on cartridge can be used in place of the normal filter element. To check the fuel pump outlet pressure, attach the pressure transducer to the Quick Connect fitting in the fuel supply passage shown here. This fitting connects to the passage supplied with pressure from the fuel pump. Watch the pressure gauge installed in this fitting during engine cranking. The pump output pressure with the engine cranking should be approximately 100 psi. With the engine operating at idle, the fuel pressure at this location in the housing should be between 230 and 274 psi. With the engine operating at 2,000 RPM, the fuel pressure at this location in the housing should be between 275 and 300 psi. To measure the pressure drop across the filter, install a pressure gauge on the fuel pump Quick Connect fitting to measure the fuel pressure before the filter. Start the engine and run it at rated speed with no load. Record the pressure. Move the gauge to the Quick Connect fitting on the fuel rail and measure the pressure at rated engine speed and no load. If this reading differs from the first reading by more than 75 psi, the filter is restricted and must be replaced. Air can enter the fuel system through leaks on the suction side. A fault code for low pressure may accompany an air in the fuel problem. Engine symptoms include rough running and slow acceleration and deceleration. If any of these indicators are present, install a sight glass at the inlet fitting to the IFSM and look for bubbles in the fuel when the engine is running. If bubbles are present in the fuel, look for leaks between the IFSM and the fuel tank. Move the sight glass towards the tank a fitting at a time until the leak source is found. To check for leaks at these locations, turn the key on. The lift pump will build up to 15 psi pressure at these locations. If fuel is seen leaking from the IFSM gasket or the cooler plate and lines with the engine off and the lift pump running, air will be sucked into the system when the gear pump starts to draw fuel. If there is still reason to believe that there is air in the fuel and none of the prior checks have located the source, remove the IFSM and check the bypass valve. Remove the fuel metering actuator for the front bank and install the adapter kit in place of the actuator. Torque the adapter plate cap screws to 80 inch-pounds. Connect the water manometer and zero the tape. Bar the engine while watching the manometer. Depending on the starting crankshaft position, it may take as much as 2 revolutions to check all 3 injectors in a given bank. If a change in manometer pressure is noticed, stop barring the engine and note the position of the valve set marks on the damper. Once the faulty injector is noted, you can continue to bar the engine through the remainder of the 2 revolutions to test the other injectors on that bank. Replace any injectors determined to be faulty. If air has been introduced into the fuel system while changing the fuel filter or other fuel system component, the engine must be run at high idle for several minutes to purge all the air out of the fuel system. Failure to do so may affect the accuracy of the cylinder performance test results. Fuel is introduced into the rails as pulses by the actuators. The actuators are solenoid valves that open and close each time an injector is fueled. If only one injector is contributing less than 70 or greater than 125%, check the overhead set on the injector and valves of that cylinder. If the overhead is set properly, replace that injector. If 2 injectors in the same bank are contributing less than 70% or greater than 125%, check the overhead set on both cylinders. If the overhead is set properly on both cylinders, replace the out-of-range injector which fires first in that bank. Identifying the failed injector in a case like this may involve consideration of more than 2 engine cycles. For example, 5 fires before 6, 6 fires before 4, 4 fires before 5, and so on. Let's take a look at an example to see how this would work. Cylinder 4 is contributing below 70%, and cylinder 5 is contributing above 125%. Consider the engine firing order 1-5-3-6-2-4. The front bank fires 1-3-2, and the rear bank fires 5-6-4. If all 3 injectors in the same bank show less than 70% or greater than 125% contribution, swap the metering actuators from front to back and determine if the problem follows the actuator. If the problem does follow the actuator, then that actuator should be replaced. When a cylinder is selected, the cutout test stops fuel delivery to that cylinder at the metering actuator. You should notice an initial drop in engine speed and then a recovery as the ECM adjusts fuel delivery to the other cylinders. Since each actuator controls a group of 3 cylinders, shorting all 3 cylinders in a bank provides an indication of actuator function. If the 3 cylinders selected are those controlled by the malfunctioning actuator, there will be little or no change in engine operation. When the 3 cylinders controlled by the functioning actuator are shorted, the engine will most likely stall.